How did a yard switcher built in 1943 by Baldwin Locomotive Works survive 66 continuous years of service, outlive multiple corporate mergers, and become one of the most unlikely locomotives ever to wear BNSF paint? December 1970, Cleburne, Texas. Inside Santa Fe's heavy repair shops, VO 1000, number 2220, sits stripped to its cast steel frame. 27 years old, originally rated at 1,000 horsepower for wartime yard switching. Now facing obsolescence amid Santa Fe's fleet-wide modernization push. Mechanics are preparing something unprecedented, transplanting an EMD 567 series prime mover and Blomberg B trucks into a Baldwin-designed locomotive. Here's the contradiction. Santa Fe is already retiring its aging non-EMD units. Simultaneously, it is rebuilding surplus F7 road locomotives into CF7 switchers at industrial scale, standardizing everything toward EMD. So why would the railroad invest significant shop labor into a single Baldwin test case? If you are drawn to overlooked engineering experiments that quietly reshaped American railroading, subscribe, because this is part of a larger investigation into the machine's history forgot. And the answer begins not in 1970, but in the maintenance numbers that made this gamble unavoidable. Baldwin Locomotive Works delivered the VO 1000 in 1943 with a cast steel frame that weighed in at over 60,000 pounds, an industrial backbone designed to outlast the engine, the trucks, even the company that built it. This was not a lightweight experiment. Baldwin's factory drawings from the era show a one-piece underframe poured in a single casting intended to absorb the relentless shock of yard service. The frame's mass gave the locomotive a higher adhesive weight than many later switchers, translating directly into more tractive effort at low speeds. That mattered in yards where every ton of steel on the rails counted. The original VO 1000 engine, an 8-cylinder, 4-stroke diesel, sat low and broad within this frame. Its configuration, cylinders arranged in a straight line, crankcase cast as a single block, allowed for a compact, accessible design, but set a pattern of compatibility that would prove crucial decades later. Baldwin's approach to mounting the engine and generator on deep crossmembers, bolted directly to the main sills, meant that even as the prime mover aged, the frame itself remained structurally sound. This attention to physical durability explains why, when parts scarcity and obsolescence threatened the entire Baldwin fleet in the late 1960s, number 2220 was not simply scrapped. The cast steel frame provided a foundation that could accept new mechanical systems. It was overbuilt by the standards of its day, and that overbuilding made adaptation possible. In a system where most non-standard machines were retired or cannibalized for parts, the sheer physical rigor of the Baldwin frame bought number 2220 a second chance. That foundation would become the platform for one of the most unusual rebuilds in American railroad history, an experiment that would test whether industrial longevity was a matter of original design or of strategic compatibility with whatever ecosystem came next. Maintenance records from the late 1960s revealed just how dire the situation had become for Santa Fe's Baldwin switchers. The mean time between repairs for the VO 1000 fleet had dropped to about 180 hours, barely a week of yard service before another breakdown. Shop logs show that even routine fixes, like replacing a piston or a generator brush, could ground a locomotive for more than 45 days while mechanics waited for parts. Baldwin had exited locomotive production in 1951, and their parts network collapsed soon after, leaving only a handful of third-party dealers and forcing Santa Fe's shops to remachine components in-house. Labor hours for these repairs climbed sharply, with cost memos from 1967 listing a 25% increase in shop time compared to EMD units. Internal cost analysis worksheets put a full VO 1000 overhaul at $37,000, including $22,000 in labor and $15,000 in parts, yet the payoff was only a few more years of service. Meanwhile, the cost to rebuild an F unit into a CF7 using readily available EMD parts was about $60,000, but promised a decade of reliable operation. These numbers made the risk of keeping Baldwins on the roster hard to justify. The mechanical department's own memos set the bar: retire units with a mean time between repairs below 300 hours or parts lead times over a month. By the time number 2220 came up for review, the data left little room for sentiment. The only way forward was to test whether a radical rebuild that replaced nearly everything except the frame and cab could deliver the economic and operational consistency that the rest of the fleet now took for granted. A close inspection of the builder's plate on the frame reveals the locomotive's layered identity: a cast iron badge stamped Baldwin Locomotive Works, VO 1000 S01 1000, bolted to the right side since July 1943. This plate, battered but legible, held the original serial number and anchored the machine's provenance through decades of mechanical upheaval. When the Cleburne shops received authorization for the experimental rebuild in August 1970, the first official act was to log the transition in the builder's plate inspection sheet. Shop Order 1270-222T recorded the removal of the Baldwin engine and the installation of a new EMD 67C prime mover, along with the addition of an EMD data plate, now mounted on the engine cradle but never replacing the original Baldwin mark. The locomotive's identity shifted on paper as well as steel. Santa Fe renumbered it from 2020 to 2450, assigning it a new place in the roster to reflect its hybrid status. Internal memos from the mechanical department show the renumbering was more than clerical. It was a signal to shops and dispatchers that this was no longer a standard Baldwin, nor an ordinary EMD. The Cleburne foreman's signature on the inspection sheet locked this transformation into the record, ensuring that every subsequent service log, upgrade, and maintenance order would trace back to both Baldwin's original build and Santa Fe's one-off experiment. This dual lineage, Baldwin's heavy frame and cab, EMD's engine and running gear, gave the Beep an identity unlike anything else in the fleet. Before delving into the specifics of what hardware survived and what was replaced, it is this moment of official redesignation that explains why the Beep's story is inseparable from the question of how industrial systems decide what to keep, what to discard, and what to reinvent. Inside Cleburne shops, the Baldwin 50-1000 was reduced to its cast steel frame. The original Baldwin diesel, a constant maintenance headache, was replaced with an EMD 567C, an 8-cylinder, 800-horsepower engine already standard across Santa Fe's roster. This swap meant parts and know-how were always on hand. The new engine sat on a custom steel cradle bolted to the Baldwin frame with gussets spreading the load. The overhaul continued with the removal of the Westinghouse generator and Baldwin traction motors, replaced by an EMD Model D15 generator and Model D77 traction motors, wired to match EMD SW 1200 switchers. Electricians stripped out the Baldwin wiring, installing a new harness built to 1970 ATSF safety standards with a 15-pin plug and shielded conduit. Controls, throttle, and switches were standardized for familiarity. Beneath, the Baldwin A1 trucks were swapped for Blomberg B road trucks, salvaged from retired EMD locomotives and adapted with custom brackets. These trucks, with their swing bolster and coil springs, improved ride and traction. Above, a new GP-style hood was fabricated from 12-gauge steel and painted Santa Fe blue. Only the cab, frame, and builder's plate remained from 1943. The rebuild demanded 1,150 labor hours and $68,000, each part logged in the ledger. For Cleburne's crew, this was a test of ingenuity, proving a hybrid could deliver years of reliable service. Cleburne's experiment left the Beep with an identity that was both practical and peculiar, a hybrid that fit nowhere else, yet proved indispensable in the daily grind of shop work. Between 1971 and 1985, service logs from Cleburne document a relentless schedule, switching cuts of freight cars, shuttling heavy loads across the yard, and filling in for out-of-service switchers. The EMD 567 engine and Blomberg B trucks made repairs straightforward. Parts were always on hand, and mechanics could apply the same skills used on the rest of Santa Fe's EMD fleet. Shop records note incremental upgrades, rewired control circuits in 1978, new cab heaters in 1982, each one logged as a routine adaptation rather than a headline event. In 1986, the Beep moved to Topeka, where it continued as a shop switcher through 1994, its reliability quietly affirmed by the lack of drama in the maintenance files. Decades of steady work, made possible by compatibility and overbuilt hardware, set the stage for the Beep's next unlikely chapter. In the aftermath of the 1995 Burlington Northern and Santa Fe merger, the push for visual and mechanical uniformity swept through the new BNSF roster. Hundreds of locomotives were renumbered, repainted, and streamlined into a single corporate image. Yet amid this transformation, one machine stood out, the Beep. Instead of a full repaint, BNSF applied a simple patch over the original Santa Fe blue and yellow. The old lettering remained, the orange stripe still visible, with only a BNSF stencil breaking the continuity. A visual contradiction rolling through yards otherwise scrubbed of such reminders. For a management team committed to standardization, this was not a sentimental gesture, but a practical concession. The Beep's unique blend of Baldwin frame and EMD parts made it an outlier, too useful to discard, too singular to assimilate. Shop rosters and merger-era photographs capture the anomaly, a lone yard switcher wearing a patched identity, outlasting peers that fit the mold. In a system built on conformity, the Beep's survival became a quiet statement about the limits of policy and the persistence of functional misfits. How did a 1943 Baldwin yard switcher outlast an industry built on obsolescence? The answer lies in documented choices: EMD 567 power for parts, Blomberg trucks for traction, and standardization for survival. Today, retrofit decisions still decide what endures. Subscribe to keep uncovering the quiet engineering bets that shape our infrastructure's future.